All right. Let's see if things are working. I think they should be good. They usually are. I just usually am hesitant off the block, but that's all right. So today I'm gonna keep plugging away at my rendering library. I'm in the middle of adding things like extrusion and revolution and all that sort of stuff in a robust way, and I have sort of a multi-paradigm data structure, right? So I've got functional representation and boundary representation functions, and rendering them out to my SVG view thing requires different bits of logic. And so I've been just kind of rolling my own sort of for loops to do that, and it's a little clunky, so I want to see if I could maybe come up with a way that sort of just encapsulates it nicely into a simple function or two. So that's what I'm gonna try mess around with today. I think I could get something useful there. Once I have that, it'll be much easier to build out more advanced 3D generating functions. So that's the idea for the day, so we can get to it. Oh yeah, one thing I did manage to get done on, well, yesterday when I wasn't streaming. If I look over here now, I've got a nice thread first macro that transforms this set of points and runs all of these different functions to produce the shape we see here. So I have extrude, which I had before, which is quite nice. If I save that, it'll update. Should update. Oh, okay. There's no exception. I'm going to ignore that for the time being, since it's fine technically. Okay, so here, right, if I change this number, this extrude number is the extrusion height, so it adjusts it on there. Just make sure things are okay here. Looks good. Scale works kind of as you'd expect. It will change the shape along the shape's axis. So I'm changing the scale along the x-axis, but it's scaling in the z, and the reason for that is because I applied the scale transformation before I applied the rotate transformation. So if I were to flip these around, it would be more in line with what you would expect. But that's an order of transformation thing, and you're gonna get those things no matter what you do. Here I've got 450 is a bit of a big rotation, but it would still work technically. Let's do that instead. Right, so here it's hard to tell, but this is a rotation on the y-axis, and because of the isometric projection, it's hard to make to understand it intuitively, but this rotates along the z-axis, and then this rotates along x. So the rotation thing, I might want to build a better approach that uses, say, quaternions, or explicitly requires you to put the axis vector or something like that. I don't know for sure how I want to do it. One idea is to follow the logic of this is OpenSCAD, which I kind of want feature parity with. So maybe it makes sense to follow how they handle rotate here, which is rotates its child a degrees about the axis of the coordinate system or around an arbitrary axis. So, you know, maybe there's something useful here. I have to see. I have to think about it. But for right now, it doesn't matter too much. It does work, and the machinery of that I can adjust as I need to. But let's go back to what I had here. Let's even do -90. And then finally here, translate should work no problem. So if I actually rotate it 0, extrude is 10, if I translate -5, this should be the center of this volume just coincidentally is going to be exactly at the center of the axes here. It didn't do that automatically, it's just the logic of how I am calling this shape, that's all. If I make this radius 10, that makes the shape a bit bigger. If I change this to 60, it'll start to look like a cylinder because there's a lot of facets on there, but it's not truly a cylinder, it's just a straight polygon. But that's fine for what I'm trying to do here. So what I can do too, let me actually just that didn't do anything. I wonder why that is. A little confused by that. Oops, that should be an error. Something might not be working the way I expect it to here. Oh, maybe it is working, I was just not thinking about it correctly. 22.5. Yeah, there we go. Right, so I've got some basic shape transformations built into the Forge library now, which is quite nice. I'm very happy with that. One of the next things I'm working on, but I want to have a renderer available to test it first, but I'm in the Forge model here, I'm working on the Revolve Operation. And this is actually a little bit challenging because it involves, you know, if you're sweeping a curve along another curve, you have to track the normal vector, but if it's not planar, so if it's going along like a helix or is in 3D space, you have a degree of freedom that you have to try and work with. So like you could accidentally have twists and all that. So sweep is actually kind of complicated. These were the first things I came up with. I don't think they're right, but the point is it's hard to visualize it. So I need to, I want to have some sort of surface rendering mechanisms in my SVG here to help along with that. So that's some of the next things to do. Okay, so I described this earlier. The Forge code base is essentially just the data model. Forge, solid modeling programs, blah blah blah. This gives you all the tools you need to make valid shape objects, which have a history, functional representation, vertices, curves, surfaces, and volumes. That's basically all this does. So that means if I want to have SVG rendering out here, I need to go to my document rendering library here, which has SVG here. And what I need to do basically is produce, I think I'm going to put it in its own namespace. Yes, that is what I'm going to do. Transforms are going to be the 2D transforms. Yes. Right. Basically, I'm gonna do. Oops, that's the wrong button. Q. Yes, yes, yes. That's fine. I meant to do this. Split. And here, instead of saving this to SVG, I'm gonna save it to. What's a good? This is gonna get confusing. I'm gonna call it shape for now. Let's leave it. This namespace is responsible for transforming shapes from the ForgeLib library into SVG renderable data. Does that make sense? Yes. I don't know if I love that, but it's a starting point, and that's okay for now. So draw is probably going to be outmoded, but I might need it to, you know, hold on to some of these sorts of things. But I'm going to attempt to kind of write this clean, following the logic that I'm using for the new Forge model approach. So what that means, what is the right approach is the first thought going through my head. Well, let's start with the namespace. Namespace stylo.shape. Let me think about this name for a second. While I'm thinking about this for a second, I'm actually just going to delete this. Just to distract myself for a minute, I'm going to start deleting a few things here. Taurus? I actually have a Taurus function? Really? How did I manage that? Huh. Well, actually, so while I'm here, let me just copy that into here for a second. Let's do primitives. May as well start with some of this. Move it into spots where it makes a little more sense. Okay, Taurus. Cylinder. VRep circle I already have up here. Surface circle, curve circle. Yeah, actually, split this and do arc, line, circle, arc. These are all still works in progress, so like because they don't have they have only boundary rep or only functional rep, so they're not completed yet. Let's actually move ellipse up because it's like kind of the same thing as arcs, right? Let me see here. Oh man, went rock climbing yesterday. And it's a lot of fun, and I'm getting better at it, but it really puts a lot of strain through the tendons in your fingers, and so I feel it right here. But hey, the pain is worth the fun, so I'm not really complaining. Just feel it in the fingers. VRep curve arc, surface arc. Let's go Taurus, VRep surface Taurus. A Taurus is actually an interesting thing where it's a fully 3D shape on its own. So there's not like a there's not an edge to it per se, right? Like this is a Taurus here. This is actually sort of a faceted Taurus, but there's not like, how do I put it? There's not, and the same is true of a sphere. There isn't really. You can have a fully enclosed surface without any edges whatsoever. So I can end up with a shape that has no edges but does have a surface and a volume. And so that's an instance where I can't, with the current rendering I have here, it's just a wireframe. So I have no default built-in way to render a shape that has no edge components to it, right? Because the actual render method I'm using here, if we ignore this, we get rid of the bounding box. This here, we can see the for thing that I'm running here. For each edge in the list of curves of the test shape, which is defined up here, take that edge and draw a line from the start point of the edge and the end point of the edge. Maybe hard to read, but this line, you draw it from edge 0, so the first point of the edge, and edge 1, the last point of the edge. But in the case of a torus, it could be a valid shape. You can even run all of these transformations on it, but it's not going to have it, like the list of edges is going to be 0 length, so it won't render anything. So that is exactly why I need to have a few different render approaches available. So a way in which I can render an approximation of a surface. If it's a curved or straight surface, doesn't matter. Edges, you know, those are important to render as well. Eventually I need to get into hidden edges and face culling and all of that stuff, but even before I worry about those things, I need something that will nicely and easily render for me whatever I want in a basic form. So that's the idea today. But back to just cleaning this up a little bit. Brep circle I already have. Brep cylinder seems pretty useful. This is a cylinder surface again. So what I can do here, sphere, torus, split this again, and I can make cylinder, and we can start with this brep here. So cut and paste, brep surface cylinder, which actually, so the kind of cool thing too about geometry is there's so many different ways to define all of these things. In this case, the cylinder is nicely defined directly by, so you just remap u and v to their domains. So the height v goes from 0 to 1 scaled by the height, and u goes from 0 to 1 scaled by 2 pi, because u is going to be traversing a circle. And then you're given, you have x, y, and z have just very straightforward mathematical equations to them. X and y are determined. This is exactly the same as the math that makes a circle edge, and then z is provided by v, which is just going to be your parameter multiplied by the height. Very easy, gets you a nice 3D point. But I could also have said brep surface cylinder is the extrusion along z of a brep curve circle, right? Like this would be equivalent R and H, where you run, you return actually a u v function, but what you do first is let C1 be brep curve circle of radius, of size radius, and then uv is just vector addition of no, pardon me, you don't even need to write it this way, because I also have a brep curve extrude operation here. Extrude, curve extrude returns a surface, right? So you give it a curve and you give it a height and it'll extrude into a surface. So I could just use that here, which would actually just, so I just return brep curve extrude C1 by H, and that will be equivalent to this like it's mathematically equivalent. They might end up with different actual values because of floating point weirdness, but theoretically they're the same. Point is, there's more than one way to skin the cat when it comes to 3D shapes. Okay, sphere, let's just better. You know what? Let's not muddy the waters here. We'll just leave it as is. Okay, sphere proto. Do I have the sphere here? I have an F rep and a B rep. It looks like I may have already managed to copy this in, which is good. That means I can just delete that, which is really nice. Okay. Let's have a look here. Okay, I can't delete all of these, but I can definitely delete those. Let me double check this circle. I think I can delete that from here as well. VREP curve circle is the whole thing. Surface circle, arc is down there. Okay. So we can delete the circle one. Can we delete arc yet? Let's not delete arc yet. I have to check. Curves. Let's check arc here. Curve arc. Let's do this. Let's go like this. Move this. I don't think this works either. This Bezier curve thing I think is broken. Which probably is going to be fine for now. I'm not using it yet anyway. It was an attempt earlier, but I have to really study that stuff anyway. Let's go here. Old arc. So the reason this is a little shaky is because it uses a parameter estimation here, which makes it an inexact solution, and it's also estimate parameter doesn't work very well yet. It's slow and prone to null pointer problems, so I don't really think this, pardon me, I don't really think this is a good approach. What I attempted to do here was basically just remap a parameter value so that it is using a circle but will never report anything outside the bounds of that circle. So 0 and 1 will be from, we'll just trace an arc perfectly to those points, but I don't know if this works either. Again, something I have to test visually, which is a little tough at first, but that's fine. This is all part of the process. Okay, VREP proto curves, iBez, Bezier. You know what? I'm going to do this. Just get rid of it entirely. CSG. Let's quickly check the CSG for a minute. FREP union. Difference in intersection. I have all of that. Oh, these are going to be useful. Actually, I should copy those. But first, let's VREP CSG stuff. Big work in progress anyway. Translate. FREP translates there. Rotate. FREP rotate is there. Scale. FREP scale is there. Good, good, good. So that means up here the proto transforms, translate, rotate. Wait a second, did I do this correctly? Let's get translate out of there for sure. Scale's also not a problem. I think okay. I think it's fine, actually. I do wonder though, maybe it's something to, maybe there's something a little more fundamental here. Although maybe not. No, you know what? I think this is probably fine. I'm gonna leave it there for now. Line. I'm not sure what I was attempting to do here. Let's leave those for now. 2D, lift and drop, that's not useful to me. Solid, sphere, box, cylinder. Okay, let's have a look at primitives, sphere, frep sphere. Is that the whole thing? That's good. Cylinder. Cut that. Frep cylinder. Perfect. Let's actually put it up here. Frep cylinder. Okay, that's good. And now we have box, which I don't actually have yet. I don't have that here yet. So that's important to add it here probably. Box. It's better than nothing. Box is kind of fairly trivially covered by doing a rectangle and just extruding it, so it's not that hard. But since I've already got something written here, I may as well give it a little copy and move it. Okay. Before I forget to paste it there. Frep box. Okay. It's a start for a lot of primitives, which is really good. Design, blah blah blah. Proto. Frep proto is the only chunk left. Splines proto. This is gonna be, this is a whole thing. Yeah, this needs a ton of rework for sure. But this was a basic Bezier approach, trying to get things to work. But I think I probably want to, make it its own namespace in this library, and 2, really rework it, because there's a lot of improvements to be made. You know what I'm gonna do though? I'm just gonna delete these. I am just gonna make that choice right now. Those are gone. Triangulation proto. Math geom. These are all things that I need to reorganize, but I do need to pay attention to all the things I need to keep for that, because these are actually important. Splines proto needs a bit of rework. A lot of rework, I should say, but the namespace is good. Okay, so things are pretty clean here in the Forge side of things, which is really encouraging. I'm really happy about that. These things seem silly, like just going through and kind of deleting and moving some bits of code, but it is actually a really good exercise in solidifying and actually making decisions about the code, right? Like, deleting code isn't bad, and writing code isn't always good. So it just, being able to move things around and clear things out and add certain things back in, it just forces you to actually decide what kind of things are important and what aren't. Clarifies your thinking a little bit and makes things neater, which is really satisfying. Okay, so that does bring me back to thinking about the mess that is this set of things, which is going to be a hard thing to fix up, but that is totally fine. Regular polygon, proto. I know I can delete this because I have that function in the Forge primitives, polygon, regular polygon points right here. Probably could even reorganize that, but I know the function's there, which is good. Grid. Okay. Okay, I'm going to finish writing this namespace. And then I'm going to get working. Require forge dot proto as f. I also know I need, why did that happen? Stylo.svg as svg. And geom, potentially this is not good to have here. Potentially, yeah, Delani shouldn't exist here. Stylo Delani shouldn't exist. Oh boy, let's see. Okay, so I do have Forge being pulled in there, that's good. Forge there. Let's call that sufficient for the time being. Let's go ahead and do that. Okay, stylo.shape. Oops. Let's save this. Let's save this. Okay. I'm gonna have to go dev stylo. I'm gonna go to the washroom for a minute. Be right back. It won't be long. Yes, okay. Be right back. I am back, indeed. Oh boy. Ooh. Well, my muscles are sore from climbing. Gotta stretch. If there's anyone tuned in live, by the way, and you want to ask questions or just chat, go right ahead. I am pretty comfortable with chat, just talking about whatever. It's fun. So if you want to engage, you go right ahead. If you don't want to, that's totally cool too. I don't mind. It's just nice that people tune in, you know? You know? Okay. Okay. Let's have a quick peek at some of the I've really gotta clean up a few things here. Builder is fine for right now. That is outside of the scope of what I'm attempting to work on today. Dimensions, probably important to keep. Offset, probably something to keep for the purpose of moving to offset should be a forge thing. Sampling, I could probably delete this, but I'm going to keep those for now because they might be important, or they might be useful, I should say, for setting up grids and stuff. Let's consolidate the sampling stuff for a minute. Grid, parametric grid, and all this stuff kind of makes sense together. At least for now, that makes sense. So we can get rid of the sampling spot here. And let's do this. If we just get rid of that. Okay, there we go. So offset and dimension 2D are theoretically fine. Triangulate surface. This here is actually probably important to have, but I don't want to have, okay, list cd stylo, list this, okay. Extensions I can ignore for now. That's gonna move, but that's something for another day. Okay, Delane should not exist. So let's have a look here. I think okay, it does not come back. It doesn't show up when I tangle, which is good. Draw should still exist. Extension and style, those are fine. SVG is good. Shape is good because it's a work in progress. And geom probably should also not exist because I want to pull that from the Forge library. So that should probably change. Right, so if I go here, vector arithmetic, some math stuff. Comparing floats is a whole big mess. It's a hard thing. So let's move comparing floats back up to the top and ignore it. Yeah. Okay. That goes up there. Maths. This slope function is only for 2D, so that's a little bit silly. Let's do this. Slope 2D and move it. Slope 2D. Let's also, round probably is good to have. See, the problem is, like, I don't know how to label these things exactly. They're not utilities than anything else. I don't know, it's a little confusing. Also, slope isn't really a utility thing so much as a geometry math thing, right? It kind of goes here. But then utilities things are more like clamp, exponent, and sine. Those are more utilities than actual geometry math, right? So see how moving these things around is kind of strange? Or not moving them around. Moving them around is fine, but categorizing them is kind of strange. Okay, but I have 2 rad and 2 degree and round are now covered in this square. Would be something here as well. And I should probably call it square exponentiate. That's annoying, but wait, does there exist something math/pow? Yeah. Is it the same? Okay, so if I have if I have 3 to the power 4, that gives me 81. Yeah, 4, 3, 64. If I do math pow 3, 4. Yeah, okay. I don't know why I did this. There might have been a reason, but I don't know it. Maybe it's because it doesn't exist in Clojure script. Maybe it does exist. Yeah, okay. Let's just delete that then. That's a nice problem solved there. And square is kind of redundant too, right? You could just, right, like if you do square 4 is 4 to the power of 2 is 4 times 4 is just 16, right? But if you just do math/pow 4, 2, it's just going to give you the same number. So that's kind of also pointless. I don't know. clamp and slope 2D I know I have somewhere else, so let's get rid of that. Bounding box. Actually, this is maybe useful to have actually in this spot. I'll have to think about that, skip it for now. Okay, linear algebra stuff. I'm almost certain I have all that stuff I need right here. Vector stuff is fine. List manipulations. Probably can get rid of these because I don't remember why I needed them. But we'll leave them there for now. Geometry calculations. Okay, slope d star dot product C3D determinant. Do I not have det here? Oh, I have square here already too. Delete that one. This bounding box. Okay. Do I have normalize even? Okay, let's do this. Bounding box center becomes bounding box center 2D. It might be redundant, but maybe not. Okay. Normalize and determinant. I think I missed those somehow. Oh, normalize is here, so that's good. Det is important. Determinant is what it actually is, so let's move it up here. Determinant AB this is only the 2D determinant. I have not produced a general one that works for n-dimensional matrices, right? So this is not finished, really. It's not great, but it's a start. Second A, first B. That's probably why I didn't copy it in there. Determinant 2D. D star, let's do dot product and cross prod product. I'm gonna run into mistakes next time the next time some things load because I've renamed these and I haven't changed the definitions elsewhere. It's annoying, but it's a one-time annoyance, so that's more or less okay. All right. Okay, floating. Let's get rid of this. Okay. Style of design. Notes and issues is big list. Style is fine. Here we go. Okay. Distance. this here I can do this way, and this here yeah, I can do this way. I wonder if this makes sense. Dot star, cross star. Yes, that's fine. That's good enough. Because yeah, okay, that I'm fine with that. Math square root. I think this makes sense. Clojure dot REPL slash source v star is just is that not a function? Do I not have that? I thought I did. Vector arithmetic v star partial mat v star. Yeah. Okay. Those all exist. So here, distance map, if I map multiply 1, 2, 3 and 1, 2, 3, I get some vector 1, 4, 9. If I do v star of the same thing, it should give me the same result. Does, okay, so that means this is a fine substitution here. Reduce by adding those together, and then you square root that, and then you get the distance between 2 points. That's perfect. Which means this is covered in there. Perpendicular. Don't remember what that note is from. Don't know if I even need this, but that goes here basically. Perpendicular 2D. Yeah, that's fine. Line predicates. Okay. I'm gonna assume that's covered fine in other things. Okay. Radius from points exists here, so we're good. Get that out of the way there. Center from points. Angle from points. Perfect. Angles. Angle from points 2D. I wonder, this probably, yes, this works. Oh, here is going to be one of those problems. Okay, we're calling that good for now though. So that's out. Oh, I should actually make sure this stays in there though. That is, I'm assuming the source of the equation that I codified here. So that's good. And now area. Okay. Triangle area Polygonal area is just triangle area mapped for all the polygons, I assume, right? Yeah, okay. So this can move over here. So we've got those. Let's actually split this into its own subsection for a minute because that's pretty useful. Okay, area is covered. Okay, that leaves the geometry totally out of the stylo part of the library, which I'm pretty sure is a good thing. There's a reasonable chance that now this messes everything up because I do need to change this to forge.proto as f, and anytime I have a g/ call, then some things are going to get a little messed up, but I can figure that one out kind of after as well, because that's just going to be tedious. Okay, that's fine though. Okay, areas. If I split this, I can call this three points algorithms. Sure, that's not perfect as a naming approach, but that's okay. Estimators. Okay, remapper, remap within is important. Okay, I'm pretty sure that's okay for right now. This voxel grid thing. Okay, now we work on the draw side of things. Forge stylo geom we don't need anymore because that's all covered from Forge in theory. SVG, F, and Delani. Okay, that is a good start there. If I go here, now I have to remove geometry. Style and extension makes sense. Builder is good because that is that compiles the markdown and stuff like that, and that's something needs to be worked on, but later. Shape and SVG are the two important things, and draw probably is going to disappear. Maybe. Draw's going to need a bit of work yet. Okay. Okay, here. Okay, now let's just since we're on the roll of going through and kind of clearing things out a little bit, let's follow through with that. Okay, let's start with offset here. I know, we'll do it up here. We'll go like this. Splines proto, we'll just split here. And we do offset proto. And what we do there is nice and simple. We take all this, cut, paste, and okay, proto is, or offset proto is moved over. That's nice. Dimensions 2D makes sense. Triangulate surface proto. Okay, so this is a starting point. These two things actually should go into shape. A starting position for those. Shape. Shape. Okay. Containers. Figure, fig, drawing 2D, axes 2D. That doesn't make sense there. See, some of these things are kind of hard to pull out properly. 3D rotation is handled in Forge, so this gets deleted. Yes. Orient X, Y, matrix, proto. Oh, this is a nice one to delete because there's nothing here. Yeah, there's work to do with matrix transformations, like just a general transformation matrix approach, but that's something out of the scope of today's work. So these all get deleted. And instead of 3D rotation, these are scene rotation, scene rotations, scene that's fine as a starting point. Yeah. Yeah. And this function here has to be replaced with, if I go into the Forge model and I look at the operations, transformations rotate, there's a function that I can use. Ooh, this, let me check things. Is this used internally? Yes, this needs a rename. Rotate point 2D. Then this is just rotate point 2D. This here, rotate point, is what I can use to do so this has to change a bit, but it's not that hard. Rotate point, if I go here and do rotate points, right, that's just going to be a map v forge/rotate point. Oh right, I also need arguments here, points. Let's not do this. We'll do this instead. No, let's do it this way. Rotate points takes points, AX, AY, AZ, right? And then it returns the result of map V f/rotate point some point rotated around Z like that over the points, and then here you run your points through the function rotate points like that, and that should be equivalent. We'll find out at some point when I test that, but that is using the Forge function rotate point, which is nice. And then this would also be rotate points like that. Yes, seems good to me. And then this is something different entirely. This is a sure, isometric axes. Maybe delete that, I don't know yet. But we have scene rotations. Drop and add Z can be eliminated, I believe. move those into shape. Scene stuff as a starting point looks good. Draw, namespace is fine. Containers, dimensions 2D, those stay for now. This is an empty category now, which is nice. Here we are, we have I deleted drop Z. Okay, this can be deleted because it was an incomplete thing to begin with. This also can be deleted because this is not how I want to do this. Shapes. All right, here we have here we've got the start of something kind of useful for shape rendering. And now we nicely have a pretty simple draw. You know what I'm going to do? These I can move into the SVG thing here because they're kind of composites. It's something. It's okay. Yeah, that's I think that's reasonable that those are sort of considered composites. And by composites I just mean like things you can draw in SVG that are combinations of the simpler shapes. So like an arrow is a line and a triangle. You can draw triangles in SVG, you can draw lines in SVG. So a composite thing is an arrow, which is just a grouping of those things. Dimensions in 2D are just some lines and arrows and text boxes, so it kind of makes sense as a composite. Maybe it doesn't make sense because you have to, I don't know. That's still a little loose in my mind, but it's a pretty okay spot to put it in, I think, for now. Arrow. Arrow, circle by points, container. Makes sense to me. Yes. Okay, things are coming together in my mind. Things are making sense. Dimension 2D. This is tabbed. This is not indented the way I like it. There we go. That's fine. Dimension 2D. That's good. Okay. Shape. Yes, I like that. Scene stuff. Okay, now finally we have a look at this. These things go away because I don't need those, because that paradigm is no longer what I'm doing. In fact, this disappears too. Okay, we are left with some helper functions for setting up grids and a triangulation function. it was a little preemptive for me to delete the drop Z function. I can tell right here. So if I do drop Z, ooh, I don't have that in this namespace. Oh yeah, if I go namespace stylo.draw, it's currently still loaded. If I do drop Z, I wonder if I can read the source of that. Clojure.repl/source drop Z. I wonder if that's, yeah, not found. That's fine, I'll just recreate it. Or maybe not. I'll just see how that pans out. Okay. Well, I did eliminate draw now, right? Remove draw. Oh, there's still something tangling into the draw namespace. Shape. Scene, probably. Shape.cljc. Shape. Save that. Oh, I did this in the wrong order. Now I have to save that. List. Vim draw. What's still getting tangled into there? Figure. Oh, that's okay. So that's oops. Okay. SVG. Tangle that there. Okay. Oh, I didn't delete the namespace thing yet. Well, that's silly. Remove draw. Right? The draw namespace call is the only thing. Okay. We really pared a lot of things down, which is scary, but I'm pretty sure it's a good thing. Build and extensions. Oof. We are getting simple, which is really nice. Okay, let's list this. Perfect. So the three files, the three namespaces that are big and relevant for the Stylo library are SVG, which has all of the definitions for things like stylo.svg/circle. It has all of the things that can be that are SVG tags. So circles, rectangle, line, path, and it has the start of a domain specific language for the path thing for like Bezier curves and stuff like that. Work in progress on that one, but it is the wrapper for SVG stuff. We have Builder, which is basically a markdown parser that has the ability to eval code blocks, Clojure code blocks, so you can render the SVG inside those into a document directly, and it is also responsible for loading files, loading, parsing, and writing, so file IO stuff, and basically CLI stuff too. Extensions I'm gonna probably move out of here as a concept entirely. Extensions are meant to be sets of functions that are useful for building specific kinds of documents. So in here I've got an extension called Fabric, which is logic around building shapes for quilt patterns. So these are all specific tools for building out those kinds of things. It kind of makes more sense to just have this be its own project, pulling Stylo in as a dependency, because then I can build the pipeline the way I want it, a little more in a more straightforward way. So that's probably going to become its own thing, but that's good for now. And the big important one is now shape, which is the connection point between the 3D models from Forge and the 2D rendering of this SVG thing. In the future, it would make sense to expand Stylo to have, so if I've got SVG, it might also make sense to have WebGL, 3D context, maybe even 2D canvas, so that I have multiple render approaches. But that's a problem and an expansion for another day. In the meantime, I have to go to the bathroom again, so be back shortly. I won't be long. Okay. I am back. Okay. Okay, so we have available to us a few different things. Let's start with something that I think is pretty straightforward. Okay. Oops. We need to go like this. All right. What do I want to? What do I want to do? Edge render. Let's start with that. You got to do something. Right, so the basic idea of this is, we'll put it in a comment because we have to start somewhere. For edge from curves of some shape, right? What you do what's the right way to think about this? Define render edges of some shape given some given some orientation, where the orientation is shape, orientation, and style. Yeah, where yeah, that makes sense. So style is the thing, it can be maybe optional, where the thing you yes, where style basically lets you control the color of the edge or the face of it or whatever, or the opacity. So it's just it's a map of style attributes. Orientation is just a function. Yeah, I mean, I guess I could do that. It's a higher order function of points like that, where you do these particular transformations, which just come from these sets of things. Isometric transform, and then this will be XY, which would be front transform, sure. And function of taking points. So it is a function, it's a higher order function, so you pass that in. This is going to be all wrong. Orientation transform. Okay, so given some shape, what you do is pass thread first shape through curves. Now you have a list of, no, let's not do it as a thread macro. What you need to do is, so it's render edges, but you can have a function called render one edge, right? Which itself can just be, so an edge is, oh, I should just, actually it should be curve, because an edge is a topological element, but a curve is a geometric element. So a curve can be a parametric equation that is like a sine wave, or it could be a straight line, or it can be an arc, or it could even be a circle. So in order to render it with simple SVG stuff, without getting really, like without, the easiest thing to do is you take the edge and you sample it at a set of steps, and then you can kind of trace a curve. You can approximate the curve with straight lines. So in order to do that, you render one curve at a time, where you're given C is the curve function. You don't need an orientation for what I'm trying to do here. Wait, is that true? That's not true. You need the orientation, and you do need the style as well. Yeah, that's fine. You could even do, we'll just do it for right now. We do, so given one curve, you're going to wonder if I could use one of my sample functions here. I sample I'm also in the wrong. Yes, okay. Load file source stylo shape.cljc. Yes, of course, drop Z. Of course I did that. Of course I did that. Yeah. That is right here. Drop Z. It takes a list of points, map V, into this drop blast. There, that should fix that. Save that. Okay, all kinds of problems. Unable to resolve symbol. Oh, that's not that. Macro expanding deafen at 58. Oh, did I leave an did I not finish? I did not finish either of these. Lazy me. If I do this, comment, save that, this should maybe work now. Really, eh? Okay, something else is wrong. What's going on here? Okay, we'll try again. Forget that noise, we do it this way. Okay, render curve does nothing. Render curves also does nothing. Save it. Try to load the file. Okay, here I messed something up. Let's get rid of that first of all. Okay. That is showing up as a problem where? What have I done? Oh, yes, of course. Here, this. I have to do points like that. Likewise here, points. I also have to change, wait, no, that's all fine. Here, this I have to change, these functions to isometric transform. And here, isometric transform. Okay, saved that. What else was going to go wrong here? No such namespace Delane. And that's fine because, well, fine, that's fixable because I can do that here. If I go forge.Delane as Delane, save that. Okay, good. We're at a stable point for the time being. The reason I was doing that, what is the reason I was doing that? Oh yes, I have to go like this. Namespace stylo dot shape. Perfect, kind of. Right, so now render curve. I can do actually do this. Let the points be sample C, sample F and steps. Okay, let's assume the function is increment, and let's give it steps of 0. Let's give it 2 steps, 4 steps. Oh, how do I do this? Okay, that's wrong. Okay. Yeah, okay, that should work. Sample however many steps there are. Wait, is step okay, that's not what I want actually. What I want is see, I don't want this, I don't want to have to calculate the step size. I want it to be let's come up with a better name for this. We call, let me get rid of slice, quad path, quad mesh. Okay, these probably I'll get rid of, but I'll leave them for the time being. Okay, so sample is almost right. It's almost what I want, but instead of doing instead of doing it by steps, what I want to do is say, hey, given this curve, give me an even spacing of 10 subdivisions. So if I do subdivide curve or something like that. Does that make sense to do in this? Because subdivision is a thing. It is a... this is tricky. I'll leave it in here for the time being. So if I subdivide, given a curve and n, what you do is step size is just going to be 1 over n. And then you just run, you map the C over the range 0 to 1 with step size. Let's see if that makes any sense. So if we run subdivide curve inc 10, okay. Oh. Do I have to do it like this? C float It almost works. Do I have to do n plus 1? If I subdivide, if I have a line and I want n to be 1, then I have two samples, just 0 and 1. Yeah, okay, so this here, this is not correct. So let me think through for a moment here. If I want n to be 2, that's 2 segments of the curve, right? Then I should have 0, 0.5, and 1. So I only have 0 and 0.5. So what I need to do here is on the end of this range, I just need to conj onto the end of the range, the number 1. Okay, that almost works, except the 1 has to be on the other side. So in order to do that, I could do into And that'll solve that. Yeah. So if I subdivide 1, I get 0 and 1. If I subdivide, let's say 5, right? I should get 1, 2, 3, 4, 5, right? I get 0 and 1, but I also get 0.33, isn't it? Oh, of course, 0.2468. Yeah, of course, not 25. Yeah, okay, that seems reasonable. If I do some prime number, I get really weird numbers, but that's fine. If I do 11, right? So I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 segments. Yes, okay. So that seems like it could work for me. Let's attempt that. Let's attempt to use that. Shouldn't be talking with a pen in my mouth like that. Okay, so render a curve. You let points be subdivide curve C with N I don't know how to do that yet. Some precision value might be important here, but let's do 20. So those are the points, still currently three-dimensional. Then all I have to do is oh geez, my brain's starting to slow down. I think I'm gonna go for another half hour or so, and we'll go from there. We'll see. Right, so style element takes some style and some element. So what that means is I actually can do something like this. Thread first points through the orientation transform, right, which will be a higher order function that takes a list of points, so it should transform it whatever way you expect. And then I should be able to take that set of points and run path svg/polyline, right, which takes a list of points. If I give it 0, 0, 1, 1, yeah, that makes sense. If I give it 3D points, does it mess up? I wonder. Oh, it does. Okay, so I do have to drop Z on that. Drop Z. Right. I think that can work. If I SVG polyline this and I run drop Z on that list, there we go. That's good. Because this orientation transform rotates in 3D space, so it does still produce a Z value on the points, which is fine. I just need to drop them because I'm projecting, assuming Z is, well, that's the assumption of how it's being projected, and that should always be fine, I think. Right, so then here I can actually run svg / polyline, takes a list of points, and then the polyline here gets transferred into the function svg / style element, which takes the style first. That's the combo breaker here. So I have to write this a little bit differently. I have to write this as svg / style element, where the style comes in here and the element comes in here. Okay, that should work. If I style the element, actually, for the edges, I should just be able to do this. Color, let's do blue, just for the fun of it for now. Okay, that's render curve, and then render curves should just be let curves be curve. I don't even need a let statement here. I can actually just do should be able to do this. Map v render curve onto the list of curves from shape. But render curve does need to take this certain form here. Curve, orientation, transform, and style. That function, map this function over this list. That's render curves. Okay, is it gonna work? That's the question. Oh boy. Let me think about a lazy way to test that. You know what, let's get rid of the bounding volume for now. Okay, here. Render curve. Render curves of test shape. And style is blue. Will it work? No. What's the deal here? Oh, I didn't do this properly. Render curves, of course, takes a list of curves. Sorry, render curves takes a shape. I need to actually write d/shape style at the end and d/orient ISO. That's not quite right. I need to scene, that's what I need. Isometric scene rotations. This here, isometric transform is I'm gonna paste that in here. The reason I'm pasting these in is because when I reload this whole namespace, there's going to be all kinds of errors because of how I change these, and I want to test my logic before I go and do all that, because that I'll probably just do off stream anyway. Okay, let's see if any of this is going to work at all. Nope. Okay, render curve. Let points be that. You don't know how to create sequence from Clojure.lang.symbol. Subdivide curve C20. Okay, let's make a curve. Def A is f/brep line from 0, 0, 0 to 1, 1, 1. Okay, right? So A what? Oh yeah, no, that makes sense. Sorry. Right, so if I do A0, gets me a point. If I do A1, I get a point. Okay, so if I do the function render curve of A with isometric transform and style blue, I get nothing. And the reason I get nothing is because I haven't reloaded the file, of course. Let's get back here. Okay, what am I missing here? Something obvious? Probably. Well, okay, does the subdivide thing work? Because I can test that. Okay, that does. It gives me a list of points, which is good. But what am I missing here? If I take this, like this instead, get rid of the let statement here. Define render is this. Okay, does that work? Okay. I must be missing something pretty straightforward here. Syntax error, compiling this function. Okay, so this maybe is what it is. I thought I was being so clever with this. Okay, so isometric transform. Oh, I have to do this? I have to double it? Maybe I'm convoluting things. I'm making this needlessly complicated. Or, well, maybe not needlessly complicated, but more complicated by doing this. Okay, so this should just be a transformation, not a higher order function, just a function directly. For how I'm using it anyway, it should just be that. That works, this works. Now does this work? Render curve. It still doesn't, and the reason for that is what? I don't know. I just need a break for a second. Okay, I must be missing something pretty straightforward here. What is happening? Okay, so if let's go back like this. Let points be subdivide curve C 20 times. That gives me a list of points. Here, I should, in theory, be able to run points through the orientation transform and drop Z. Let's start there. Let's comment the rest of that stuff out. And let's start there. So if I go up to a render curve call. Okay. So that does work. Let's try this. That does work. Makes a polyline. Here, now, this might be where it's falling over, and the reason for that, I guess, is related to this is the function, and I need to call the function like that. Is that what it is? Okay, that works there. Ah, yes. Okay, fill non-stroke blue. Perfect. Well, that was a little convoluted there. That's my bad. And this isometric transform here should change back to this. So if I save this, it might theoretically work now. Oh, of course, subdivide curve is not in the namespace yet. So let me pull that up as well. Where did it go? Grid. Subdivide curve. Save that. And drop Z. Of course, all the things, all the little things that I immediately forget that I delete. Nice thing about working with small functions is they're pretty easy to recreate. Here it is. That doesn't make sense to me. Render curves. Is that just typo? Orient. That's strange. What? Why is this happening? I don't get it. Okay, well now, so A, oops. What? Okay. A is just let's do def. Well, let's actually do this. We can actually just copy this into this REPL. Okay, test shape is now the same as the shape in the web browser. If I render curves of test shape with isometric and the color blue. Wrong number of arguments passed. What am I doing to myself? I'm going crazy. Shape. What? Okay. Render curves. Wrong number of arguments. 3 passed. What? There are 3 arguments, right? Are there not? Shape, transform, style. What's happening? Render curves, shape, test shape, isometric transform, blue. I am very confused. Okay, it works with that. Shape. Okay. Transform. Render curves, shape, isometric. Test shape. Okay. Style. I don't know what I missed, but something was weird there. I must have missed something. That's very strange to me. But in any case, now all I theoretically need to do is map v, render curves, curve with the transform and the style, and you map that over the list of curves from the shape. Okay, that should work, right? It doesn't fail, but it doesn't work either. Okay, render. Oh, because I'm calling the wrong function here. Okay, let's try that now. Okay, we have something there. Let's try that now. Save. It should fail because there's no okay. Render curves, and this has to be f/ rotate points. Ooh, no, rotate points. Right, that I'm almost there. Okay. Oh, well, we've got something not working. Okay, rotate points doesn't exist, and the reason for that is because I've moved okay, here we go. Rotate points. I have to put in here for a temporary moment. I'm very close to done. I think. That's not true. Something's gone wrong with this. I think I may have messed it up, to put it mildly. That's a bit of a shame. Let's go comment from there to here. Does this work at least? Render curves. Yeah. We don't even have... This doesn't work. Oh, is test shape? No, test shape exists. Yeah, okay. Okay. Well, what I could do, I'm gonna do one thing. This app I need to restart and fix up. What I'm gonna try to do instead is briefly I'm gonna see if I can save this SVG file to disk and open it that way. That might work. We'll see. Okay, so def B is this thing. So B is if I go to builder slash stylo.builder slash no match. Oh, I haven't loaded that in a while. Load file source slash stylo slash builder.cljc. No such file. It does exist. Builder. Source, stylo, shape. Oh, I just typoed it. Builder, not biller. Hopefully it loads. Alright. Now I haven't compiled an SVG in a while. So the namespace here does have hiccup, which is good. So that means I should be able to do stylo.builder/html. I suppose not, eh? Hiccup. Maybe I can just do it like this. Hiccup.core/html of B. Silly. Okay. Hiccup.core/html stylo.svg/svg of B. There we go. Now we can do spit that whole thing. Spit this thing into a file. Okay, now this is getting crazy convoluted. Test.svg, open test.svg. Let's see if it looks like anything. Let's also figure out what it opens in. I don't know. I wonder if it'll open in Inkscape. I'll find out soon enough. Nothing, I suppose. Give me 1 second. Maybe I can just try it directly. It didn't work. Okay. This is the file open here, test.svg. It didn't actually compile. It didn't compile things properly, and I don't know why that is. It's because of something. Let's see here. svg/path given it's been too long since I've poked through this, so I forget how to use it all properly, and then I'm making silly mistakes. Okay, path. Polygon path. I want okay, path polyline is the function I'm supposed to be working on, right? Okay, that kind of works. Except the there's nothing. Oh, I didn't call this with the right. Okay, of course. SVG/SVG needs some more data. Width, height, scale. Of course. Let's do 800, 800. Scale of 1. And the content can be something. This one, for example. There we go. It properly puts the path in there. Okay. Let's zip back up to this and put in some scale and size information here. It's wrong, hey? Nil is not a valid element name. B, last of B is, okay, let's do last of B is nil. So if I this is related to, okay, B is, if I turn B into list, first of B, okay. I think it's because I map V'd instead of just mapped. I did something wrong with, well, I don't think this should maybe fix it. Okay, on the right track to test some kind of shape here, and it doesn't work. We're getting somewhere, but we're getting there slowly, I'll tell you that much. Let's make the scale 25. Refresh this, zoom back out this way, inspect this element. The reason for that I can't figure out. Oh, I wonder if stroke width should be, nope. Well, okay, we're getting on the right track, but that is gonna have to be enough for me for the day. Not much to say. I feel pretty productive today. It was obviously a very quiet stream. That's fine with me. But if you're watching this at some time in the future, please. Oh, hey, Warm Codes, you joined right as I'm thinking about heading out. Before I do that, how's it going? If you care to chat for a minute, just yeah, just wondering how it's going for you. Did you literally just join now? Or have you been there for a bit? Trying to understand what this project is about. Would you like me to give a very brief explanation before I head out? Would that be helpful to you? First time on the stream? Oh, well, welcome. Glad you could tune in for a minute. I could give you a very brief explanation. Unfortunately, You got a recommendation on Twitter. Huh. Well, that's great. Slowly things are making their way around, I guess, eh? I'll see if I can give a very brief explanation of what I'm trying to achieve. What I can do actually is showcase, this is a bit of a site I have. I've got a few older things here. This is an old project I did. I built a stand for my iPad Pro, and I built it with this metal here. This is stainless steel tube. And what I did, I designed it in, this was Python, but it was code that generated a 3D model. And this particular article, I embedded some 3D models of the shapes that I designed. And each code snippet here, it's a little bit kind of ugly, but it produced a 3D model, right? And I was able to actually, for all of these, it's just 3 pieces and an assembly here. I was actually able to produce it like in reality, right? Like I made it with a this is a laser tube cutter machine, CNC, and this is the actual. Those are the actual parts there. So the whole thing that happened here was I made a program that produced a 3D model set that I could make a real thing out of. So in general, it's called programmatic CAD, is a term people have used. But I didn't really want to use Python for a bunch of different reasons, but so I eventually moved on to using Clojure, Lisp language, and I'm working on building out a more robust or more complete 3D modeling platform that I can use to make 3D model documentation. One of the ideas behind it, so another one of the old ones here was I built this thing, and I have the 3D model code for all of those things as well. Same idea, but now I'm trying to make a Clojure-based program that can let me do a little bit more. So this is just a tiny little thing that, this was a really rough idea. This is a quote-unquote toolbox that it's just a component that I use that I can get Clojure data pretty quickly to make things. And the whole idea is to use Clojure to make little programs that you can use to make different CAD designs. This particular one is a sample for making fabric cutout templates for making quilts. Is there anything? I also have this is a little more recent of an example. If you let it load, here I've got a isometric view. This is rendered in SVG here, and this code is what produces that file. So I can change the code and it changes the model live there. It's pretty rough. It's obviously not that ergonomic, but the idea here is, you know, you could make designs and expose a web page that has spots that people can manipulate, and then they could see design changes live, right? So this here has, in theory, you can have a rendered view with some critical dimensions on there, right? And you can, if I change this base height to 3, it changes the shape of this, but it also changes the dimensions here, so you know theoretically, oh, the drawing is now different. So that's a really off the cuff, maybe a kind of bad explanation. If you're still there, I am, if you have questions, if that's not clear at all to you, please go ask in the chat. I'm not sure if that's helpful. Yeah, I do have actually, let's see. Yeah, no, I don't know. Really good explanation, looks very interesting. Well, glad you understood it. I do have to get going soon. I'm gonna very quickly see if I can put a link on the screen. I have if you go into my Twitch channel, videos or whatever they're called, do I know what I'm doing? No, I don't. Where do I go? How do I do this? Okay, if I go here, if you go to videos, okay, so I haven't totally edited things down, but this here, if you go to my Adam James TV /videos, I have a highlight and upload video here, what I'm trying to do, talking about values and goals. That kind of lays out high level the philosophy and idea behind the code I'm trying to write. And I also have a few other ones in the highlights: programmatic CAD project examples, thoughts about programmatic CAD, and sharing design ideas. So if you want more clarity and you have a bit of time to poke through those, you go right ahead and look through there. Oops, I don't need to show you how to watch a video. I'm sure you know how to do that. But yeah, so in the highlights and uploads, I've got a few other things that hopefully could shed some light. I hope that's okay. You caught me right at the tail end of my work for the day. Right when my brain starts to shut down more. So it's not the smoothest delivery of an explanation, and yeah, I just hope it's a bit useful. It's a little lame because the culmination of my work for the day has resulted in a single blue line on this screen, so it's not not exactly a promising show for the day, but I do promise that there's other stuff going on. Mostly interested in functional programming, but take a look and watch the video. Sure, no worries. Well, thanks. Well, so if you're interested in functional programming, I'll tell you right now that what I'm working on is chock full of functional programming, and I'm not being silly. I'll very, very briefly show you what I mean by that. I have in this REPL here, I don't know how familiar you are with Clojure or a REPL anyway, but I can interact with my code live in this window. I have previously defined a shape, a 3D object, to be, I just gave it a short variable named A. And so A, if I look at the keys of the map here, A, it contains data in these different keys: history, functional representation, vertices, curves, surfaces, and volumes. I'll take this frep of A for a minute here. So A is a data structure, and inside one of the keys of A, I actually have a higher order function right here. And this is a functional representation of solids. What that means is, let's see, shader toy, SDF example. A functional representation of a 3D object is basically, it's a cool method that lets you do all kinds of visual mathematics. These here, these objects in this scene are all what are called SDFs, signed distance functions, or signed distance fields. Basically, it's just a mathematical function that if you give it a point in 3D space, it will calculate the scalar value of the distance to the surface of an object from a point. Blah, blah, blah. All that is here is if I run this frep a and I give it a 0.123 in 3D space, it gives me a distance. Since this is negative, that means that particular point is inside the volume of the shape that I use to define A. That's not necessarily functional, that's just a higher order function being passed around kind of as data, which I think is really cool. But what makes this powerful is what I can do here is I could map this frep of A, so I could run this function over a list of any points in 3D space that I want. So I could do the point 0, 0, 0, the point 10, 20, 30, 23, or any point I can imagine, right? And then if I run this, it'll really nicely give me all of these values, right? And then, so you can imagine if you want to make a discrete set of points in the 3D space, you could map a single function over that whole volume and get the distances and then do something with those distances, right? So what I can do further is filter on with some function, which is a predicate. What do I want to do? Negative? Is that a predicate? I don't know if that's a predicate or not. Let's see. Yeah, so I could do this, right? Imagine I've got a long list of points from this, right? I can filter with the predicate negative this whole thing, and now I only have a list of distances that are negative. And you know, so I do have to get going soon, but if you're still around and listening, I guess I'm just pointing out that if you're interested in functional programming, this is actually a pretty, in my opinion, interesting use case of functional programming methods, because geometry is extremely full of things that are really nice to map. So one final little thing that I think is pretty cool as well, if I define B as the first curve off of the list of curves from A, B is a function as well. So B is a different kind of function. It's not one of these. It's a parametric curve function. So it will take a single value and give me back a point in space. So I happen to know that this is a straight line. So here you can see the first point of the line is at 10, 0, 0, and the second point of the line is at 5, 8.6, and 0. And so you can do exactly the same thing. You can map B over a range of 0 to 1 with a step size of 0.1 to get discrete points along that curve. So I think it's a really powerful way to get a lot of cool 3D data out of things, and it would be even easier to explain it if my visuals were working, but I messed it up today. So that'll be tonight, and tomorrow's work is getting it all working smoother again, and then I can actually showcase some nice 3D modeling stuff using functional programming. So that's me yammering on a little bit, but if that was helpful to you at all, I hope so. Thanks for tuning in, and I hope you have a good day. I'm gonna get going. Yeah, that's all I got. I'll be back again tomorrow streaming. Thanks a lot. Hope you'll join someday sooner. Yeah, I'd love to see you around. Feel free if you. I'm not sure. Your screen name seems familiar. You may have given me a follow earlier. I'm not sure. If you have not, please. It'd be great if you followed on Twitch. If you subscribed on the YouTube VODs channel, anything like that. You know the drill. You know the help me out drill. Anyway, thanks for tuning in. I'll be back again tomorrow. If you're around tomorrow, that'd be great. Otherwise, I try to stream pretty regularly, so you just tune in during the week sometime, and there's probably going to be something there. So hopefully I'll see you around. I'm on my way out, though. Have a good one.